Hello everyone, I am Shalini and I am here with you all with some problems of trigonometry. We had already discussed the concepts of trigonometry in another video. So if you have not seen that video, so I will suggest you to go and see that video first, and then it will be easy for you to understand these type of questions. The questions which we have selected are the type of questions which are generally asked in the board examination. So it will prepare you for the board examination. So let's start. From the figure, find the value of 25 sine square theta plus 2 cos square theta minus 10 theta. As we had discussed in the previous video of trigonometry, that sine theta is the ratio of perpendicular and hypotenuse, and cos theta is the ratio of base upon hypotenuse. Here, if we are considering the angle theta, that means perpendicular will be the side opposite to this theta. That means perpendicular will be 8 centimeter, base will be 6 centimeter, and hypotenuse will be 10 centimeter. So when we are having the values of perpendicular, base, and hypotenuse, we can find the value of sine theta. Sine theta will be perpendicular over hypotenuse, that is 8 upon 10, or we can say it as 4 upon 5. Similarly, cos theta will be base upon hypotenuse, that is base is 6 upon 10, we can say it as 3 upon 5. Similarly, we know that the value of tan theta is the ratio of perpendicular to base. Perpendicular over here is 8 and base is 6. So, the ratio of perpendicular to base will be 4 upon 3. Now, we are having the value of sin theta also, cos theta also, and tan theta also. When we will be keeping these values in this, whatsoever is required with us, so we will be finding the value. So, how we will be solving it? 25. It is your sine square theta. That means sine theta is 4 upon 5. So, we want 4 upon 5 whole square plus 2 times of cos square theta. Value of cos theta is 3 upon 5. So, it will be 3 upon 5 whole square plus it is minus sign. So, we will be taking minus sign minus tan theta. Tan theta is 4 upon 3. So, we will be solving it further. So, it will be 25. 4 square will be 16, 5 square will be 25 plus square of 3 will be 9. 9 multiplied by this 2, 9 2s are 18 over 25 minus 4 upon 3. If we will solve it further, we have to take the LCM of this bracket. So that will be your 25 into 3, that will be 75 will be the LCM. Or we can solve these two parts first even. That could even be written as 25. 18 plus 16 will be 34 upon 25 minus 4 upon 3. Because both of their denominator is 25, so we will be adding it directly. So it will be 34 upon 25 minus 4 upon 3. So now we will be taking LCM, that will be your 75. Now for converting this into 75, we need to multiply and divide it by 3. So 34 multiplied by 3 will be 4 3s are 12 in 102 minus, for making it 75, we need to multiply it by 25. 25 into 4 will be 100. So it will be 25 multiplied by 102 minus 100 will be 2 upon 75. 25 3s are 75. So the value of this will be 2 upon 3. So the value of whatever was required, it is your 2 upon 3. That means if we are having all the perpendicular, base and hypotenuse, we can find all the trigonometric ratios, and by that simply we need to keep the values and we can find the answer. Now let's see the another question. In triangle PQR, in which angle Q is 90 degree? So first of all, we will be making a triangle. In this Q is 90 degree, this is 90 degree, so this is your Q. We are asked with 1 plus sin P over 1 plus cos P. So we are taking this as P, PQR. The value of PQ is given to us as 8 centimeter. That means this is your 8 centimeter. Now PR minus QR is 2 centimeter. That means PR is 2 centimeter more than QR. So we are assuming let QR be x centimeter. So if QR will be x centimeter, PR will be 2 plus x centimeter, or we can say x plus 2 centimeter will be the length of PR. Now we will be keeping it over here. QR we have assumed to be x centimeter and PR we have assumed to be x plus 2 centimeter. Now we are having all the three sides. So by your Pythagoras theorem, because it is a right angle triangle, by Pythagoras theorem we can find the value of x. So according to Pythagoras theorem, hypotenuse square, that is PR square, will be base square, that is PQ square, plus perpendicular square, that is RQ square. Now we will be keeping all these values. So we will be getting PR is x plus 2 whole square. It is 8 square plus x square. Now it is your a plus b whole square. So a plus b whole square is a square plus 2ab plus b square. So expansion of this bracket will be a square plus 2ab, 2 into x into 2, that is 4x, plus b square is 2 square, that is 4. 8 is 64 plus x square. Now here x square, it is going to cancel. So your 4 times of x is equivalent to 64. This plus 4 will go over there, will become minus 4, and it is equivalent to 60. So value of x will be 60 divided by 4, that is 15 centimeter. That means the length of RQ or QR is 15 centimeter, and value of RP will be x plus 2, that is 15 plus 2, or we can say it as 17 centimeter. Now we are having all the three values, all the three sides of a right angle triangle. So we can find the trigonometric ratios also. Now it is asked for angle P. That means if we are considering this angle, so we know that the perpendicular will be x, that is your 15 centimeter. Base will be 8 centimeter and hypotenuse will be x plus 2, that is 17 centimeter. Now we are having all the three sides, that is perpendicular, base and hypotenuse for the given angle. We know that the value of sine of P, sine of any angle, it is your perpendicular to hypotenuse. So value of perpendicular is 15 upon 17, that is your hypotenuse. Value of cos P, cos of any angle, it is base upon hypotenuse, that is base is 8 upon 17. Now we are having the value of sin P also, we are having the value of cos P also. So we need to find 1 plus sin P over 1 plus cos P. Now keep the values of sin P and cos P over here. It will become 1 plus sin P is 15 upon 17, and the denominator it is 1 plus cos P is your 8 upon 17. Now we will be taking LCM in the numerator also and in the denominator also. So it will be, numerator will be 17 is the LCM. It will become 17 plus 15. In the denominator also LCM is 17. So it will become 17 plus 8. So numerator will be 17 plus 15 will be 32 over 17, and denominator will be 25 over 17. Now these two 17s are going to cancel and the value of this will be 32 over 25. So this is how we can find the values. If we are having some expression by Pythagoras theorem, we can find all the three sides, and once we are having all the three sides of a right angle triangle, we can find the values of the trigonometric ratios, and by that, by keeping the values over here, whatsoever the expression is asked, we can find the value. So the next question is, if cosec A is root 2, then find the value of 2 times of sine square A plus 3 cot square A upon 4 times of tan square A minus cos square A. There could be two methods of solving this type of questions. Either from here we can find all the three sides of a triangle, or what we can do is from here we can find the angle, what is the value of A, that is what is the angle, and if we are knowing the angle we can find all the values. Now here suppose we know that the value of cosec A root 2 is given to us, and cosec is root 2 at theta is equivalent to 45 degree. That means angle is your 45 degree, because at cosec 45 the value is root 2. Now when we know the value of theta is 45, so sine 45 will be 1 upon root 2. We know that. Cos 45 is even 1 upon root 2. Means value of sine 45 is 1 upon root 2 and value of cos 45 is even 1 upon root 2. Now we want is tan 45 and cot 45 also. So value of tan 45 is equivalent to value of cot 45 and it is equivalent to 1. All these values we can find from the table. We have already learnt in the previous video how to find the values of all the trigonometric ratios at some specific angles. Now once we are having all these values, we will be keeping these values here in this expression. So it will become 2 times of sine square A, means 1 upon root 2 whole square, plus 3 times of cot square A. Value of cot A is 45 and cot square A will even be 1 only, because cot 45 is 1. So square of 1 will even be 1 only. In the denominator it is 4 times of tan square A. Value of tan 45 is 1. So tan square 45 will even be 1, minus cos square A. Value of cos 45 is 1 upon root 2. So it will be 1 upon 2. Square of 1 upon root 2 will be 1 upon 2. So we will be solving it further. So the numerator will be 2 multiplied by square of 1 upon root 2 will be 2 only, plus 3. 2 and 2 both are going to cancel. In the denominator it will be 4 multiplied by, here we will be taking LCM and that will be 2. So it will become 2 minus 1 in the denominator. So numerator part will be, this is your 1 plus 3, and in the denominator it will be 4 multiplied by 2 minus 1 will be 1 and by 2. So 3 plus 1 will become 4 divided by 4 multiplied by 1 upon 2, we are going to cancel, it will be 2 only. So the denominator will be 2. So the value will be 2 only. So value of all this expression is your 2. We can find either by finding the value of theta, or we can find by finding all the sides of a triangle, right angle triangle. By that method even we can solve it. The next question is, prove that cosec A minus cot A upon cosec A plus cot A plus cosec A plus cot A over cosec A minus cot A is equivalent to 2 times of 1 plus cos square A over 1 minus cos square A. So what we will be doing, we will be taking the LHS part and we will be proving this equivalent to the RHS part. As I told you earlier even in the previous video, that whensoever this type of question comes, we generally try to convert all these, means all the other trigonometric ratios, in terms of sine theta and cos theta. Here angle is theta is your A, so we will be converting all these in sine A and cos A. So cosec A could be written as 1 upon sine A. We have taken the LHS part, we are solving this part. Cot A could be written as cos A over sine A over, again cosec A here, so it could be written as 1 upon sine A. Cot A could be written as cos A upon sine A. This part we have taken. Now here again same, cosec A will be written as 1 upon sine A. So we will be writing it as 1 upon sine A, and cot A will be written as cos A upon sine A. In the denominator same we will be doing 1 upon sine A minus cos A upon sine A. Now we will be taking the LCM in the numerator also and in the denominator also. So in the numerator, it will become, because denominators are same, sin A everywhere. So it will be 1 minus cos A upon sin A divided by 1 plus cos A upon sin A. This part we have done. Then here even denominators are same for all the cases. So it will be 1 plus cos A over sin A divided by 1 minus cos A over sin A. So if we will divide, so this sin A and sin A both are going to cancel. This sin A and this sin A both are going to cancel. This will become 1 minus cos A upon 1 plus cos A plus 1 plus cos A upon 1 minus cos A. Here it is 1 plus cos A, here it is 1 minus cos A. Plus sign is there in between, so we will be taking LCM. So LCM will be 1 plus cos A multiplied by 1 minus cos A will be the LCM. Now 1 minus cos A will be multiplied by 1 minus cos A. So this will become 1 minus cos A whole square plus 1 plus cos A will be multiplied by 1 plus cos A. So it will be 1 plus cos A whole square. So see, it is A minus B whole square. It is A plus B whole square. So A minus B whole square is A square minus 2AB plus B square. We will be expanding with this formula. And this expansion will be A plus B whole square is A square plus 2AB plus B square. So here we will be expanding by the identity formula yours. So A square plus B square minus 2AB. 2 times of A is 1 and B is cos A. So 2 times of cos A. This is the expansion of your first bracket. Then for the second bracket, A square plus B square plus 2AB. Now in the denominator, it is A plus B, A minus B. Expansion of that will be A square minus B square. So it will be A square minus B square. This will be the expansion. Now see over here, cos square A positive, cos square A positive, it is minus 2 cos A, it is plus 2 cos A. So minus 2 cos A and plus 2 cos A got cancelled and it will become your 1 plus 1 will be 2. Cos square A plus cos square A will be 2 times of cos square A upon 1 minus cos square A. Here in the numerator, we can take 2 common because in both the two terms, 2 is common for both the two. So we'll be taking 2 common and the numerator will be 1 plus cos square A upon 1 minus cos square A. And this is your RHS part. RHS part is this only, 2 multiplied by 1 plus cos square A upon 1 minus cos square A. This is your RHS part. So we will write it as equivalent to RHS and hence proved. So whenever there is proving questions, either we can go from LHS to RHS or we can go from RHS to LHS. So it is easy to go from here to here because whenever we are having any terms, irrespective of means, they are not in terms of your cos A and sin A. So better to go for convert it into cos A and sin A, and if we will be solving it further, we will be coming to the things which is required to us. So we are here with the next question. If sin theta minus cos theta is equivalent to 0, then find the value of sin 4 theta plus cos 4 theta. So here it is given to us that sin theta minus cos theta is 0. It is given. That means sin theta could be written as equivalent to cos theta. And we know that sin theta and cos theta are equal at theta is equivalent to 45 degree. Either from there we can find it out, or we can say that sin theta upon cos theta is equivalent to 1. If sin theta is equivalent to cos theta, that simply means sin theta upon cos theta is equivalent to 1, and sin theta upon cos theta could be written as tan theta. Tan theta is 1. If tan theta is 1, that simply means your theta is 45 degree. Now we have decided that the value of theta is 45 degree. So we know that sine 45 degree is 1 upon root 2. Similarly, cos 45 degree is 1 upon root 2. Already it was given that sine theta is equivalent to cos theta. That means sine 45 is 1 upon root 2 and cos 45 is 1 upon root 2. Now we will be keeping these values over here. We have to find the value of sine 4 theta plus cos 4 theta. Here sine 4 theta means sine theta whole raised to the power 4. Cos 4 theta means cos theta whole raised to the power 4. Now sine 4 theta, value of sine theta is 1 upon root 2. So it will be 1 upon root 2 whole raised to the power 4 plus cos 4 theta means 1 upon root 2 whole raised to the power 4. So this will become root 2 into root 2 is 2. Now 2 times if we are multiplying root 2 we are getting 2. So if we will multiply root 2 4 times we will be getting 1 upon 2 multiplied by 2 plus 1 upon 2 multiplied by 2. So it will become 1 upon 4 plus 1 upon 4. LCM over here is 4 only. So it will be 1 plus 1. We can write it as 2 upon 4 or 1 upon 2. So value of sine 4 theta plus cos 4 theta if sine theta minus cos theta is 0 is 1 upon 2. Now the next question is, if cosec theta plus cot theta is p, then prove that cos theta is equivalent to p square minus 1 over p square plus 1. Value of p is given to us. Again, it is in terms of cos theta and cot theta. So we will convert in terms of your sin theta and cos theta. So value of p is, cosec theta is 1 upon sin theta. Cot theta is cos theta upon sin theta. Again, sin theta will be the LCM. So the numerator will be 1 plus cos theta upon sin theta. This is the value of p. But here we will be taking RHS part and we will be solving RHS equivalent to LHS. So p is 1 plus cos theta over sin theta. So over here p square is required. So we will be finding the value of p square. So p square will be 1 plus cos theta whole square upon sin square theta. We have squared this. This was the value of p. For p square we have squared this. Now it is 1a plus b whole square. So expansion will be a square plus b square plus 2ab. A is 1, so it will be 2b, that is 2 cos theta over sin square theta. This is the value of cos your p square. P square value is 1 plus cos square theta plus 2 cos theta upon sin square theta is the value of p square. Now we are taking the RHS. RHS is your p square minus 1 over p square plus 1. This is the value of your RHS. We have to prove it equivalent to cos theta. So instead of p square we will be writing this. So it will be 1 plus cos square theta plus 2 cos theta upon sin square theta minus 1 over, in the denominator again it is p square, so we will be writing the same 1 plus cos square theta plus 2 cos theta upon sin square theta plus 1. Now in the numerator we will be taking LCM, in the denominator we will be taking LCM, and in the numerator and denominator LCM will be sin square theta only. So the numerator part will be 1 plus cos square theta plus 2 cos theta. Now sin square theta will be multiplied by this minus 1. So will become minus sin square theta upon sin square theta divided by, denominator part will be 1 plus cos square theta plus 2 cos theta plus sin square theta multiplied by 1 will be sin square theta divided by your sin square theta. Now this sin square theta and this sin square theta are going to cancel. So the numerator part will be 1, we will be writing it as it is, cos square theta plus 2 cos theta minus sin square theta over denominator is 1 plus cos square theta plus sin square theta could be written as 1 plus 2 cos theta. Now see here that 1 could be written as sin square theta plus cos square theta, right? Or we can write sin square theta as sin square, we know the identity that sin square theta plus cos square theta is equivalent to 1. So sin square theta could be written as 1 minus cos square theta. We can write sin square theta as 1 minus cos square theta. So we will be writing this. This will become, numerator will become 1 plus cos square theta plus 2 cos theta minus sin square theta it is. So it will become minus 1 plus cos square theta. Because value of sin square theta is 1 minus cos square theta. So value of minus sin square theta will be minus 1 plus cos square theta. So instead of minus sin square theta, we have written minus 1 plus cos square theta. In the denominator, it will be 2 plus 2 cos theta. Now see, this plus 1 and this minus 1 both are going to cancel. Cos square theta plus cos square theta will be 2 times of cos square theta plus 2 times of cos theta divided by 2 could be taken common in the denominator. It will be 1 plus cos theta. In the numerator, we can take 2 cos theta common. So 2 cos theta we have taken common in the numerator, and the remaining will be cos theta plus 1. And denominator is 2, 1 plus cos theta. 2 and 2 cancelled. 1 plus cos theta, 1 plus cos theta cancelled, and it is equivalent to cos theta. And it was your LHS. So it is your hence proved. So this is how we can solve various type of questions. Hope you must have understood these type of question, how you will be solving if these type of question comes. Do practice more and more questions. The more questions you will be practicing, the more your doubts will be clear, the more confidence you will be giving, and the more you will be prepared for your exams. Whatsoever the problem you face in solving the question, do comment me. I'll solve and I will give the in the videos, even either I will be giving you the solutions, and otherwise I'll be telling you how to solve these questions. Thank you.